Hello everyone, myself Akanksha Sunil Sawant and my roll number is 2053016. I am here to present Computer Organization ISA 2 and my topic is addressing modes. In this video, I am going to explain what is addressing modes with its various types. Let's see the introduction. So, what is addressing mode? The different ways to specifying the location of an operand in an instruction are called as addressing mode. In addressing mode, we specify the location of an operand in an instruction that we want to execute. Operand can be placed either in one of the processor register or in memory. This means the operand can be either stored in the processor register or in an memory to carry out the computations that we need to perform. Types of addressing modes. Uh, there are various types of addressing modes which we are going to see in the details. First is immediate addressing mode. In this addressing mode, the operand is specified in the instruction explicitly. Instead of address field, an operand field is present that contains the operand. In other addressing modes, the operand is directly deals with addressing fields, none with the operand field. But in this addressing mode, uh, the calculations is directly performed on the operands. Let's see the diagram. That this is how we can represent the immediate addressing mode. There are two cells. First contains the opcode and second is the operand. Opcode is a short of operation code, and opcode is a single instruction that can be executed by the CPU. Let's see the example. Add 10 will increment the value stored in the accumulator by 10. Add in this add is opcode and operand is the value stored in the accumulator. By executing add 10, the what will be the value of the accumulator will be incremented by 10. Move R move R hash 20. Initialize the register R to a constant value 20. This is how we perform the initialization. Move is a opcode here and R is now our operand, and hash 20 is initialized to the R. Next, register direct addressing mode. In this addressing mode, the operand is contained in a register set. The address field of the instruction refers to a CPU register that contains the operand. No reference to memory is required to fetch the operand. Um, in this addressing mode, the operand uses register set to store the value of the operand. This is the diagrammatic representation of register direct addressing mode. Here we can see the register represents the value in the operand. Let's see the example. Add R will increment the value stored in the accumulator by the content of register. We can see whatever the value that accumulator holds will be incremented by the value stored in the register. Let's see next, register indirect addressing mode. In this addressing mode, the address field of instruction refers to a CPU register that contains the effective address of the operand. Only one reference to a memory is required to fetch the operand. This is the dramatic representation of register indirect addressing mode. Uh, in direct addressing mode, the register directly deals with the operand, but in this register set is used as a medium to go through the operand present in the memory. Let's see the example. Add R will increment the value stored in the accumulator by the content of memory location specified in register R. The example we see in register direct addressing mode is same as we used here. The only difference is the register set is used to perform this operation. Next, direct addressing mode. In this addressing mode, the address field of the instruction contains the effective address of the operand. Only one reference to the memory is required to fetch the operand. It also called as absolute addressing mode. This is the diagrammatic representation of direct addressing mode. Opcode A. A represent A is indirectly represents the operand in the memory, and the operand is the value on which the uh, calculations are going to be performed. Add x will increment the value stored in the accumulator by the value stored at the memory location x. Add is here opcode and x is now our operand. Um, this by when this statement is executed, the value stored in the accumulator will be increment by x at the where the location x represent. Indirect addressing mode. In this addressing mode, the address field of the instruction specifies the address of memory location that contains the effective address of the operand. Two references to memory are required to fetch the operand. This is the diagrammatic representation of indirect addressing mode. Um, let's see the example. Add x will increment the value stored in the accumulator by the value stored at memory location specified by x. Let's see index addressing mode. In this addressing mode, effective address of the operand is obtained by adding the content of index register with the address part of the instructions. Effective address is calculated as content of index register plus address part of instructions. This is the diagrammatic representation of index addressing mode. Opcode and index register indirectly addressed through the register set, and A gives the address of operand. Let's see relative addressing mode. In this addressing mode, effective address of the operand is obtained by adding the content of the program counter with the address part of the instruction. Effective address in relative addressing mode is given as content of program counter plus address part of the instruction. The diagrammatic representation of relative addressing mode is given as this. Here also the second part A indirectly represents the operand in the memory. Here PC refers to the program counter. Let's see base register addressing mode. In this addressing mode, effective address of the operand is obtained by adding the content of base register with the address part of instructions. The effective address of base register addressing mode is given as the content of base register plus address part of the instruction. The diagrammatic representation of the base register addressing is displayed. In this, base register represents refers to the register set, and A as usual represents the operand in the memory. Auto increment addressing mode. In this addressing mode, after accessing the operand, the content of register is automatically incremented by the step size d. Step size d depends on the size of operand accessed. Only one reference to memory is required to fetch the operand. This addressing mode is special case of register indirect addressing mode, where effective address of the operand in auto increment addressing mode is given as content of register. This is the diagrammatic representation of auto increment addressing mode. Now let's see auto decrement addressing mode. In this addressing mode, first the content of register is decremented by step size d. Step size D depends on the size of operand accessed. After decrementing, the operand is read and displayed. Only one reference to memory is required to fetch the operand. This address mode is again a special case of register indirect addressing mode, where effective address of the operand in auto decrement addressing mode is given as content of register minus step size. This is the diagrammatic representation of auto decrement addressing mode. Here we finish with the types of addressing mode. Thank you.